large number of pores, and these ions can basically try to fit inside a what do you call it, a cavity or a pore like this, right? Nobody knows how these ions are going and sitting inside, absorbing inside the cavity, right? Is it in a very orderly fashion or something else? Nobody knows, and that's the reason why there's a lot of interest in these kind of the fundamental studies on how this works, by changing the porosity characteristics. How do the supercapacity behavior vary? All sort of things. A lot of theory studies are going on as well to understand this actual mechanism. Okay, most of the things are still not very clear, though we very confidently say, but some of the things are still hidden and needs more understanding, and that's one reason that the state-of-the-art technologies, or strategies include, characterizing these things. For example, can I use some techniques like, let's say, NMR, right? Nuclear magnetic resonance measurements, right? To really understand, for example, if there is a charge which is going inside the pores, in situ, during this charging, can I monitor this, right, using NMR? Can I probe this activity using NMR and assume that, once it gets completely charged, do you expect some change in the signal that you observe corresponding to the charging? Similarly, when these charges are discharged, when these charges move out of the pores, do you expect some change in the signal of the NMR? Correct? And these are showing some good indications, clearly revealing the mechanism of charge storage. Okay, that's one recent area of focused research on using these kind of operando methods to understand the fundamentals, understand the mechanism of charge storage in these systems. Right? Now, somewhat